It's time to get and go and gather up your stuff. Let's head on out and have some fun. Chasing down the gold at the rainbow's end, prospecting America. We'll do it all together, yeah, now you and me, digging, panning, sluicing in search. Off on an adventure, living life so free, prospecting America.
Prospecting America is brought to you by Tesoro Metal Detectors.
Sunny Prescott, Arizona. Today, folks, we're going to take a tour of the factory of Tesoro Electronics. We have a couple of gentlemen here. They're going to help us with the tour. They're also going to give us some information on how and where you use metal detectors, what you find with them, and some of the science on metal detectors, how they work and why they work. I'd like to introduce a couple of the gentlemen here that are going to help us with the tour and also give us some of the science today. First,
James Gifford. I'm the Vice President of Tesoro Electronics, and I'm also in charge of marketing.
all right, and
Vince Gifford. I'm also Vice President here, and I'm in charge of engineering.
all right, gentlemen. Well, I'm looking forward to this tour and what we're going to learn today on today's show, so let's go on inside.
Let's go.
First stop on the tour is where they actually wind their coils. Maybe you can tell us how this works.
Well, we've got a machine here set up that is a stepper motor, has a program memory. We just take the wire, run it over, get it ready to start, hit the start button, and it actually knows exactly how many winds to put on and at what speed, so the coils have consistency.
All right, now, I noticed this little gurgling machine here. What does this do?
This is actually a little spot that has alcohol in it, and it's putting alcohol on the wire, which wets the glue. That's how the coil actually forms.
So there's a glue on the wire then?
Glue on the wire, yep.
And so when it winds together like that, it kind of sticks together then?
It'll come off as one solid piece.
Okay, and what's the next step after this?
The next step after this is we'll take it off here. It'll be wet with the alcohol, and we'll run it into an oven to dry it. Get all that alcohol out of the coil.
Well, that was pretty quick. I guess you could make quite a few of these in a day, huh?
That's the idea.
All right. Well, I guess we'll just take a look at this the oven and see what the next step looks like. Okay, so the next step of the process is baking these coils. Is that right?
That's correct. What we do is we use this oven here to bake out the alcohol and make sure that the glue gets firm on all of the windings. Very simple process. Just open them up.
Put the coils in and bake them up. How long do you have to leave them in there?
Somewhere about 20 to 30 minutes.
Okay, so that doesn't take long at all.
Not very long at all.
All right. And once you get the coils baked, then what, they go into the plastic housings?
At that point, they'll go into the housings, and then they'll get wired.
They get put into the housings, and then they get tested, and then you put the epoxy on them?
Correct.
And then the next process is putting the metal detectors together, huh?
That is correct.
Well, maybe we'll go downstairs and take a look at that process.
Good. Let's go down.
All right. Well, James, this is the main part of your factory here. Maybe you can just give us a little background on the company, how many different types of machines you make?
Well, we make about 9 different detectors here domestically. We also make a couple of different private labels for our UK and European guys. We really kind of differentiate our detectors based on the features that they have. We try to match the features that the detector has to the needs of the metal detectorist. For an example, a beginner doesn't need a high gain, big knob type of detector. What they're looking for is something that's simple, and that's where we have the Compadre. When you get into gold prospecting, those guys want high gain. They're looking for very small targets. They're going to want some kind of discrimination so they can knock out the iron. And also in our Lobo, we have what's called an automatic ground balance, which knocks out the mineralization effects and allows us to get the best depth and sensitivity.
How many dealers do you have around the country and I guess around the world?
We have about 350 dealers here in the United States and in Canada. I have 5 different distributors on the European continent. I have 1 in Moscow and 1 in Australia.
Well, I guess there's treasure to be found all around the world.
Everywhere.
Well, I think now we want to talk about the science of metal detecting, and we're going to move around over here, and we're going to talk to Vince. And I think the first thing we want to talk about is actually what kind of technology goes into these coils.
Well, the basic coil starts off with windings here. You have a transmit on the outside and a receive on the inside. Then those windings are basically tuned and potted, and then we do a final coat so you see what you have as a production coil.
So there's a signal that comes out of the outer coil and then receives back into the inner coil. Is that how that works?
That's correct.
Okay, and maybe we can kind of see a graphical demonstration of how that works on this machine right here.
Well, the big sinusoid that you see here is actually the transmit coming out from the outside.
Okay.
And the little guy is the balance. And if you watch the little guy, you'll see on iron, for example, that we get a signal that looks like this. Whereas a quarter is
it's a totally different signal.
It's a totally different signal. You have two components, phase and amplitude. Amplitude is how big it is. The phase is where the peak is coming out. So this gets us our discrimination based on phase, where this is a nickel and a quarter's over here.
So the electronics in the machine itself will discriminate between where the peaks are in those different waves and say, okay, this is a quarter, or this is a dime, or this is a nickel. All right, well, that's really interesting. Maybe we can see a few more things. I have my my ring here. I'm going to pull off and see what that looks like on that machine there. So I guess that would be one that you wouldn't want to discriminate out, right? So it kind of goes right up this line right here.
Right, if we get it here, you can see that it's peaking right about that point.
Okay.
And again, if we go back and look, you'll see that a nickel is close, but a little different. A little different. And a quarter is in that same neighborhood.
It's in the same neighborhood.
And then this is actually a piece of ferrite that we use for ground effects, and you can see that the ground is almost in phase with the transmit.
Okay, so explain to me how you ground balance a machine.
When you get in ground effects, you're looking to add half of what's going up with half of what's going down and come up with a zero.
I see.
That's
okay.
Actually the balancing portion of it. It lets you eliminate this and still see this.
Well, I found their engineering department. This is the most fascinating part of the process, in my opinion. This is the part I enjoy. This is Vince's domain. Now, Vince, you actually design each of these component boards for each of these machines. Is that right?
That's correct.
And what kind of a process is that?
Well, you start with the design, and then you actually lay out the printed circuit board in software and send it off to actually be made here. Or to be made and sent back.
Now you actually make those boards right here with these machines right here.
We buy the boards raw, but we bring them in-house and populate them here.
Okay.
I'll show you that process if you'd like.
Sure, let's take a look at it.
All right.
See how it works.
We're going to start with we're going to start by putting solder paste onto the boards. We've got a laser cut stencil here.
So this is a metal sheet that has holes already in it.
That's correct.
And it puts a little bit of paste where all the components are going to get glued onto.
That's correct. It's almost like printing a T-shirt. It just basically puts it on, almost like ink. And we're going to pop this guy out. Now this guy has the solder paste on, goes over to the pick and place machine.
What was this called again?
This is called the pick and place.
The pick and place machine. All right.
The machine actually goes and picks components up and places them on the board. And it does it a whole lot faster than I can.
Well, it's like one of those movies you see it speeded up. It's actually a robot, I guess. It puts those parts right in place. So I guess the software that's programmed in there, you program all that in there so to make sure it's done right.
Program that as well, and we have different programs for each of the different units that we manufacture. So we've got a lot of software here, and we just change things for each one of the units.
Wow, this is absolutely fascinating, and each one of those little pieces does a different thing, right?
Different task on the board. Yep.
So what are some of the parts that are being laid on there right now?
The big parts that you can see are mostly ICs and capacitors, voltage regulators, amplifiers, those types of things, and a lot of that's set by resistors that are pretty small, almost so small it's hard to see.
Okay, so that one's done, and after it comes out of there, it goes to where?
So once the board is done, now we've got paste with components set on it. We're going to pull it out and take a quick check and make sure everything's where it's supposed to be and that everything is there. And then we're going to put it into this oven. We've actually got a 4-chamber oven that warms up the circuit board, gets it and holds it hot,
okay,
and then actually melts the solder in the last chamber.
So right now you've got one that's going through the cooling process, looks like.
Right now it's just come out of the oven. The solder is actually still liquid, but it's cooling down and solidifying up, and when it comes out the end, it'll be cool enough for me to handle it.
All right, and then it comes over on the workbench over here, and then you have a technician that solders some more parts on, right?
They'll solder the last 5 or 7 or 10 parts onto it.
Okay, and the finished product looks something like this, I guess.
Yep.
That's what actually makes the machine work right.
That's what actually does all the thinking and drives everything.
All right, well, let's see what the finished product looks like.
All right.
Well, we just got done making a circuit board back here. Now, once they're made, what happens next?
Well, what happens then is we'll take the circuit board and then we actually wire all the switches onto the faceplate and then also into the control housing. Now, this is for a compadre, and then at that point, everything will get pushed down inside and that'll be closed up. And what we do is we make sure that the electronics has been tested and checked with the coil.
Okay.
And then once it's all closed and before we put it into the box, we test it one more time just to make sure that we haven't missed anything or done anything in the closing. And that's the basics of our process, the electronics assembly process.
So what happens if somebody's out in the field and something goes wrong with the machine? What happens then?
Well, we have a lifetime warranty on all
A
our
lifetime
products.
warranty, that's
Yes.
good.
And in 25 years, we probably see about 1 to 2% of our detectors come back. A good portion of those come back from just people wanting to get everything tuned up, make sure everything is working perfectly,
Right.
so when they get out,
Well,
they know it's working
definitely.
great.
It's got a lot of pieces and parts in it, that's for sure.
You bet, you bet. So we do that, we get everything taken care of.
Well, here's some of your different machines right over here, but also I see you have some coils set up here. Now, some machines can take different coils, or do some machines set up for specific coils?
Most of our detectors have interchangeable coils, and you want to be able to change coils so that you can fine-tune your metal detector to make sure that it's working for what you're looking for. So,
Well, the coil that we made upstairs was a round coil. I see this is sort of the shape of a D. This is like a double D coil, then, right?
that's correct. That's a wide scan coil. We normally use those when we're looking at a situation where we've got heavy mineralization. Wide scans, as a general rule, will see less ground effect,
I see.
but they're not as good a discriminator.
Okay.
The Lobo SuperTrack comes stock with a wide scan coil. Most of all of our detectors come with a concentric coil. As you can see, the difference here is we've got the 2 Ds on the wide scan, then we've got an inside and an outside coil.
On this one, you have the transmit and the receive. How does it work on this one?
You have the transmit, and then the receive is on the other side.
I see.
So you develop a hot spot across the middle, even though you create a field all the way across. This one is a little bit better to pinpoint with because your hot spot is much more in the center here,
Right.
whereas on a wide scan it's going to be from the heel to the toe of the coil.
So when you're going across the ground, you're going to have this whole section is going to be where the best detection is.
Correct.
All right.
And that helps a lot, especially when you're working with small targets.
Now, what's the difference between size? If this is a big one and this was a small one, what's the difference in those?
Again, you're looking at trying to fine-tune what you're doing to match with the coil. A smaller coil will concentrate the signal. The signal is not going to go as deep, but it becomes much more sensitive. So a small coil is great for nugget hunting when you're working with real fine items. A bigger coil allows the signal to penetrate deeper, but it loses a lot of the sensitivity to it. So if you're searching for really big nuggets or you've got a cache that you know that you're looking for, use a bigger coil. It's going to get that better penetration on bigger targets.
So if you're looking for gold, if you're looking for smaller pieces that are fairly shallow, you want to use something like that.
Correct.
If you're looking for bigger pieces that are deeper, something like this, or some double D or something like that.
Right, and this is a 12 by 10 wide scan. Again, you can kind of see the shape of the coils in here, whereas this is a concentric, so that you can see the outside and the inside.
Okay, well you have some machines set up here, and it's like about 7 or 8 of them here. And obviously this is the one underwater one because it's all waterproofed, and you've got the headphones for underwater. Maybe you can just tell me about some of your different features on some of your machines.
Okay. Well, what we do is, again, try to match the features to what a customer is going to use. Probably the easiest detector to use is the Compadre. It has one knob. It's turn on and go. There is nothing to fiddle with except for how much discrimination that you want to use.
And what sort of application do you recommend this one for?
This is mostly just coin hunting, very, very simple relic hunting. You're not going to see incredible amounts of depths out of this guy. The next step up would, in this particular group here, would be the Conquistador. Now the Conquistador has an on-off sensitivity, has a discrimination feature on it, also has a frequency shift on it. And the frequency shift is used mainly for guys that are working in a coin hunt, where there's a number of other people that may be using the same frequency that you are. You're able to switch the frequencies. You can also use it to basically take out some of the background stuff, maybe in an area where there's a lot of high cell phone traffic. You can use that to knock out that kind of stuff and still get that depth and sensitivity. The DeLeon is a very good, nice, easy to use, simple turn on and go machine. It's got a very simple meter to read, and it's got some good information on it. Not quite as much as its brother, the Cortez. These are basically using the same type of circuitry. The Cortez has a little bit more bells and whistles. It's got a 9-segment bar graph. It does have a notch filter discrimination feature on there, which will allow you to knock out certain portions of the target spectrum and still keep your nickels and gold rings and things like that.
Excellent.
Also, we've got our Tejon here. Tejon is designed more as a relic hunter. It's got a very high gain sensitivity on it.
Now you mentioned gain. Maybe you explain a little bit about gain, what that means.
Okay. When you're working with a detector, the coil is going to transmit a signal and then receive it back. On most of our coin machines, we have a gain of 10,000 to 1, which means the signal is sent out, it comes back, and then is amplified by 10,000 times. The Tejon and the Lobo SuperTrack have a gain of 1 million to 1. You're going to get a little bit better depth out of it, but you're really going to see more sensitivity. It's for finding the real small items or finding getting a little bit better signal off of items that are deeper. The Lobo SuperTrack has an automatic ground balance on it. And this is really especially useful for when you're prospecting, because that will allow you to tune out the ground and let the machine keep its highest sensitivity so that you're going to be able to find nuggets on a more consistent basis.
Another thing that a lot of times I have trouble with is hot rocks. How do you deal with hot rocks?
Well, there's two different ways. If you're using a manually adjusted machine, you can actually change the ground balance slightly to cover that particular hot rock. Unfortunately, at that time, even though you're not going to see the hot rocks, you may lose a little depth or a little bit of sensitivity. The Lobo SuperTrack actually has different windows that it will look in to see where the ground balance effect is happening. In the normal soils mode on this guy, you have the smallest amount of ground balance, so there's not going to be very much effect that's happening in there. The widest amount of gain, so you're going to see the most amount of sensitivity to the small nuggets. By going into the alkali mode, you actually increase the window, and the hot rocks are more likely to fall out into those areas. So you're going to see a lot less hot rocks, but you're still going to see that nice sensitivity to gold.
All right. Well, being able to recognize what the hot rock is really a big deal, because a lot of the places I go, there's hot rocks everywhere, and it gets kind of frustrating. And if you can tune those babies out, it's going to save a lot of time.
It does indeed.
All right. We have the pleasure of having the founder of Tesoro Metal Detectors here, Jack Gifford. Jack, welcome to the show.
Thank you.
Pleasure having you.
Pleasure.
And maybe you could just tell us when you got started in metal detectors.
Well, I was working at Motorola Semiconductor, and a salesman came in one day and told me that a company named Space Data had bought a company in Klamath Falls, Oregon named Bounty Hunter, and I knew my layoff was imminent, so I went down and talked to Bob Walker, and he hired me, sent me to Klamath Falls, and the rest is history.
Do you get a chance to go out and do much metal detecting yourself?
Well, yeah, I've been. I used to really get into coin hunting here in the Phoenix area where the company started, and I went treasure hunting in England for a couple of weeks one time with my distributor, which ruined me for coin hunting in America. I came home with targets that 70 or so coins that I'd found that were from the first 3 centuries. And
wow. Well, what's the most favorite thing that you've ever found?
Oh, probably the best thing I've ever found is an old crossbow Roman toga clasp, and that was a real thrill for me to find something like that.
I thought I saw something like that on your counter around here somewhere.
Yeah.
A toga clasp. Wow, look at that. So that's what about
Well, that's probably the 2nd or 3rd century.
Wow.
It's a magnificent piece. Of course, you can see where the pin that they used to do the toga clasp thing is
So that was
away. It was
some
an
Roman
iron
governor or something, huh?
Well, who knows?
Who knows? Well, that's really interesting.
Yeah.
Well, we've been taking a nice tour of your factory here, and your people have been gracious enough to give us a nice show and give us some information on the technology of metal detectors, how they work, and we really appreciate it.
Yeah.
And
Well, I'm really proud of the crew that we have here, and I'm especially proud of my 2 sons, and Myrna and I are basically ready to retire, and the kids are going to take over, and I'm sure they'll do quite well with it.
so it looks like Tesoro is going to be around for a while.
We hope it will, yeah. We hope so.
Well, Jack, it sure has been a pleasure, and
Very
appreciate it a lot.
talking to you.
Take care.
Thank you.
Well, part of any operation is quality control, and I guess that's what this department is here, huh?
That's right. This is the final test where Carl is actually testing the unit exactly the way that the customer sees it. It's a non-technical, no scopes. Does it turn on? Does it sound off? Does it discriminate? Does it look good?
Well, you got to be thorough on those sorts of things. 'Cause I wouldn't be happy if I opened it up and didn't work.
That's true. That's true. Nobody is.
Well, that's good. You guys do pay attention to detail. Excellent. Well, this is the last stop on the tour, where you do your boxing and shipping.
That's correct.
So you ship quite a few of them out of here, huh?
Yep, everything's ready to go to the customers.
All right. Well, you know, Vince, I really do appreciate the tour here today, and I'm sure the folks at home appreciate some of that information. It's been a pleasure having you on the show.
Well, thanks for
I've got my metal detector here. I'm ready to go find some good stuff.
All right. Well, good luck to you.
We'll see you next time on Prospecting America.